Welcome. We are CLF Alberta, Carbon Leadership Forum Alberta, and we are part of a hub of a larger group of organizations. So we have our website, CLFalberta.com, but there is also the wider Carbon Leadership Forum.org that has tons of information to do with embodied carbon, everything to do with toolkits, to policy, to information on case studies. So I highly encourage everybody to check out that website and get more involved and see, you know, a lot of people are further along in their embodied carbon journey, especially with exciting things going on in the University of Washington, et cetera. So just wanted to make sure everyone knows about those resources. It's one of our missions at CLF Alberta to radically reduce embodied carbon in buildings and infrastructure. So education, of course, is a key piece of how we do that. I want to say a special thank you to Alberta Eco Trust and NBIX, the Emissions Neutral Building Information Exchange. So they're our host sponsors for the event today. So thankfully organizing our Zoom links and making sure we're all organized. So a special thank you to them. Without further ado, I will introduce a member of CLF Alberta, Christina Mikhailuk. So she's out of Calgary at Footprint there, and she is our life cycle analysis expert. And we have exciting updates today for not only our rating systems and LCAs, but through the concrete and steel industry as well. So we're excited to give those today. Please feel free to put questions into the chat. We probably will just wait for natural pauses and insert where we can, but we'll be monitoring the chat, so feel free to use that. And yeah, as I mentioned, this will be recorded and we can watch back later, but we'll make sure to post that on LinkedIn and everything when we're done. But yeah, I think we're ready to get started. So Christina, I'll pass it off to you.
Excellent. Thank you so much, Kirsten. And thank you so much, everybody, for being here today. Really excited to be able to talk a little bit about some industry updates within embodied carbon. And I think we've got some great additions to our group here with Farid and Shane as well to do some industry updates from cement and from steel. I'm just going to share my screen here. Please let me know if everything's looking good there.
Nothing yet. Sorry, I'm not seeing it.
Oh. This isn't my first rodeo, I swear.
There we go. Looks great.
There we go. Perfect. Okay, thank you so much, Kirsten. Excellent. So as Kirsten said, I'm Christina Mikhailuk from Calgary and Footprint and with part of CLF Alberta as well. So really excited to be able to talk to everybody here. This is just a brief agenda that we have for today. I'll be doing a brief conversation about guidelines and rating system updates. And then we've got some information on steel current trends and low embodied carbon steel from Farid Safari and concrete current trends and low embodied carbon concrete from Shane Mulligan. So just to start briefly with the guidelines and rating system updates. So I know that for those that are really familiar with embodied carbon or for those that are kind of new into the embodied carbon realm, it can be a little bit overwhelming as things seem to be changing quite fast. Over the last couple of years, especially since the release of LEED version 4, we're seeing a large increase in the amounts of life cycle assessments that are being required throughout municipalities and through different jurisdictions, as well as certifications and standards that are kind of coming up. So some of the items that I wanted to just talk about briefly in terms of guidelines and rating systems are some really exciting items that have been recently released. So first one I wanted to discuss briefly was the National Whole Building Life Cycle Assessment Practitioner's Guide. The name does go on, but we can just call it the NRC Practitioner's Guide, as well as the recent release of the Zero Carbon Design Framework version 4 from the Canada Green Building Council, as well as the LEED version 5 public preview. So just for just brief information regarding the whole building life cycle assessment, as I kind of mentioned, we are kind of looking at you know, something that's still really new to the industry, and there's a number of institutions and rating systems that have started adding embodied carbon and life cycle assessments into their own documents. But through this, we do end up seeing a bit of an inconsistency between how each of these different bodies are governing how life cycle assessment should be done, especially in relation to the baseline design. And then even such thing as what type of gross floor area should we be using, what's our specific definition for that, as well as really important guidelines on how we should actually be comparing an embodied carbon assessment from what is proposed building through what is a baseline building. So the NRC practitioners guideline that has just been recently released, it is currently in its final draft, and it is anticipated that the full public release will be available within the next couple months. But this is some really important guidelines that people are able to take a look at in order to assess embodied carbon and how to demonstrate reductions, especially for new construction and renovations. So this is a really great document that should give you some great indicators on what is baseline, how to do reductions, some great opportunities for in terms of how material takeoffs are being completed. And for those of you that may be familiar with the City of Vancouver, they've released some embodied carbon guidelines, I think it was last year, their final draft. And this is essentially a buildup on top of that. Anthony Pack was one of the developers of this. So for those of you that have read those specific guidelines, which I think were kind of leading the industry at the time, this is kind of to build on top of that. And this will also be used in conjunction with the other National Research Council information on whole building life cycle assessment. One thing I wanted to point out directly from here is gross floor area. They have their specific definition of gross floor area. So it's really important as we start to see life cycle assessment pop up and how we're intending to use this information, especially for gross floor area as it's used within the embodied carbon intensity, that these definitions may actually change from specific definition to definition. So based on the NRC guidelines, they do talk about what gross floor area means to them. And an important exclusion is that it does not include attached garages, including underground garages. So this is really important to making those definitions, as it's not always clear what gross floor area people are using and the scopes that are included in there. Another exciting recent release was the zero carbon building design standard from the Canada Green Building Council. So we are now on version 4 of this, and this is really, really exciting. This is just released on June 4th, and it is now open for registration. For those of you that may have been working on zero carbon projects under version 3, or were thinking about doing it, it is still actually open for registration until September, but there is a 2-year, sunset on being able to get your project certified. So just be aware that if you are still looking at version 3, you would need to have that project registered before the end of September, and then it would need to be submitted to the CAGBC by the end of September in 2026, and this would be using your issued for construction documents. So this one here is really exciting in that it's updated some language in terms of its reference documents. So now you can see it actually includes that life cycle assessment practitioner's guide that I had just mentioned earlier. But there are some differences in terms of the actual definition. So they actually use a different intensity number for gross floor area based off of the built floor area, which actually includes underground parking. So there are some differences between these different systems on what your result might be for a zero carbon building may not be what it is going to be for a LEED building or a building under a different system as such. This also provides some clarity on where you have multiple buildings that will be shared with an underground parking garage. Sorry, my eye is just watering here. And then there's also going to be some updates in terms of the embodied carbon intensity. So we're actually taking a look at a update in where there is 425 kilograms of CO2 per meter squared. And just remember that meter squared does include the underground parking area or parking areas. And then there's additional requirements or different requirements if we were actually looking at warehouses and distribution centers. So the previous number for this used to be 500 kilograms of CO2 per square meter, and it actually followed the gross floor area was based off of the LEED reference for gross floor area, so that actually did not include underground parking. With this one here, we do see that, as well as the improvement of baseline over 10% reduction, which is similar. And there's also some updates to the innovation strategies, but for the most part, they are following a 20% and 40% reduction. And then on top of that, there was some minor updates to what that reduction would look like for the warehouses and distribution centers. But it's still, for the most part, the same type of system. They do let people know that they should be evaluating embodied carbon early, and that they should also be taking a look at trying to find ways of actually reducing it and not just hitting the thresholds. So there are, because as if there are projects that may go for the zero carbon performance standard as well to get that additional certification to show that net zero design, that the embodied carbon would need to be offset as well. And LEED version 5, so this one's a bigger section here. Obviously, I'm not going to go over every single thing in the slide here, but there are some very big updates to LEED version 5 in terms of embodied carbon. Version 5 was released for public comment in April, and I do believe that the comments have closed now. If that is incorrect, my apologies. But this is going to be looked at as a future release in 2025, and there may be some minor updates based on the public comment that comes out. But in terms of the key impact areas, we are taking a look at decarbonization as one of the really big impact areas in terms of operational carbon, but also in terms of embodied carbon. So through that update, embodied carbon assessment is now considered a prerequisite, but how that is looked at is not necessarily a whole building life cycle assessment. It is a bit of a different scope of work, but they now do prioritize it to the point that it's going to be required for all LEED projects. In addition to that, projects that are actually pursuing a platinum, which is the 80 plus points, will actually have to reach specific decarbonization thresholds, which actually includes embodied carbon. So it does state that you need to hit 2 points within one of the specific LEED credits for this. And another thing that's important to note is that what we see pretty much across the line for life cycle assessments is that this includes the enclosure as well as the structural systems. The LEED version 5 is actually also pointing to the addition of hardscape materials as part of the scope. So not to go into too much detail here, as I want to make sure that Fareed and Shane have enough time to talk about their really exciting industry updates as well. But this is just a quick preview of what the prerequisite is for the LEED version 5 called Assess Embodied Carbon. So this one is essentially taking a look at tracking the global warming potential and quantities covered by materials through, using an LCA or EPDs. And what's really interesting is that they're actually taking a look at a minimum amount of materials that they want you to explore. So for them, that would be the asphalt, concrete, cement, structural masonry units, insulation, glass, steel used in the structure's enclosure, structure, and hardscape at a minimum. So this is essentially what they want you to take a look at. And then there are taking a look at it based on A1 to A3 scope. For those that are a bit new to embodied carbon, A1 to A3 is looking at the product material itself. So that would be the extraction, the transportation to manufacturing and manufacturing of a product. And what's really interesting here is that we do want to compare against a baseline global warming potential values. There's a bit of an image on the right here, which shows what some of these values are looking like based on asphalt or concrete. Some of these values are similar to what the CLF 2023 baselines were, but not exact. So just important to note that there's going to be some differences in terms of what we're seeing for benchmark global warming potential. But for the actual prerequisite, we're not looking at any type of reduction, it's just assessing. In terms of how to earn credits in embodied carbon through reduction, they've now made this big change where there are 4 different options to get up to 6 points under the reduce embodied carbon framework. This one obviously continues to include the structure, enclosure, and hardscape materials. And then again, parking structures within LEED boundary would be included in that. And then I noted the platinum projects require at least 2 points between options 1 through 3. So option 1 is going to be a pretty standard whole building life cycle assessment, taking a look at a cradle to grave scope of work. And the points are based on a 10% increase. So 10%, 20%, 30%, 40% is what we're looking at for our points. There isn't super strict guidelines about what the baseline is at this time. Based on the notes, it is saying that it is an equivalent building in terms of the massing, the terms of the operational energy, but we anticipate there'll be a bit more guidelines or maybe some updates to that going forward. Options 2 and 3 are also taking a look at these specific materials within the life cycle assessment, but not through a whole building perspective. So we're taking a look more at what your procured product looks like in comparison to a global warming potential benchmark. So for option 2, there is a benchmark that LEED has specifically put down. In terms of option 3, this is a benchmark that is created by a different third-party member. But this is being taken a look at through EPDs and other information. And what's really important to note is that all these are actually based on as-built materials and quantities. So this would be something that you would end up submitting during your construction submission based on the information that we have right now. Something that is really exciting here is option 4, which is actually tracking your carbon emissions from construction activities. So this would be that A5 module that we would take a look at. So there are points available depending on specifically what is being tracked or who is tracking it, but this would be taking a look at fuel and utility usage on the job site for either contractor, or you can look at contractor, subcontractor, as well as the fuel usage from material deliverables and waste hauling. So this is really exciting that this is something really new to embodied carbon and how we're taking a look at it, but there's also bunch of different ways to be able to do embodied carbon and make an impact through a whole building life cycle assessment, all the way through procurement of embodied carbon materials and EPDs. One thing I did not mention is that there is another prerequisite as well that requires the prerequisite here under assess embodied carbon to be a part of a 25-year study. So they essentially would want you to take this embodied carbon assessment that you have right here, and then there's going to be some multipliers that you add on top of it. One multiplier is a 0.5 multiplier in order to take a look at expected MEP contributions and interior like plumbing items as well. And then there's an additional multiplier, I believe it's 0.25, that would actually assess renovations. So there's an anticipation that there would be a renovation at the 10-year mark and at the 20-year mark. So that was a very fast-paced, big look at the industry updates for guidelines and embodied carbon rating systems that have embodied carbon. LEED v5 will be looking at coming out next year, and the zero carbon framework is already out. But just one thing to keep in mind is that we want to make sure that we're looking at the definitions and understanding what our gross floor area definitions are. But it's really exciting that we're taking a look at other ways of looking at embodied carbon, and it's not just going to always be a whole building life cycle assessment, that there's going to be other areas of opportunity as well. All right, so I want to hand over next to Farid Safari, who's going to be talking about steel, and he is with Sealer Middle Dofasco. I think that's the first time I may have said that hopefully correctly, Farid. But Farid is a project manager of sustainability at ArcelorMittal Dofasco. He is responsible for sustainability projects, including life cycle assessment and product carbon footprint evaluation for AM products across North America. He has a PhD in mechanical engineering and a master's in renewable energies, and is an expert in hydrogen and industrial decarbonization, assisting in decarbonization team at Dofasco to develop lower carbon solutions in steelmaking. So I'm really excited to hand it over to Farid and learn a little bit more about the industry updates from the steel perspective.
Thanks. Thank you, Christina. You hear me well and see the slides?
You're looking
Just
good.
let me know. Perfect. Thank you, and thank you, CLF Alberta, for this opportunity, and everyone joined. Welcome to this talk on low carbon emission steel for sustainable construction. So basically, we go over the industry update on steel and what we offer as low carbon emission steel. So first of all, just kind of a just quick introduction on the impact of buildings on carbon emission. You explained a bit of it, but like if we take a look at overall global GHG emission, we see the different sectors contributing to it. So on the right, you see the building contributing to almost 28% of the global carbon emission. So of those 28%, 20% is associated to operational and 8% to building materials, which we call like embodied emission that we will go over. So that's how important it is, and it contributes significantly to the global carbon emission. And then if we just kind of define the operational versus embodied emission, this is from the CLF website, by the way, and embodied carbon represents the carbon emission associated with making building products and construction from raw material extraction to manufacturing, transportation, and end of life disposal or recycling. So you see different sections here from raw material supply, construction, installation, and the operation in the use phase of the building, which is mainly about the energy use of the building, the basically the carbon operational carbon emission that we defined shown in blue. And then why that matters. So basically, we know about the climate change and global warming and environmental problem, but in our business, why that matters. So it comes to policies. So federal greening government strategy and municipal and in different level policies that are legislated for the embodied carbon. So federal green government strategies disclose embodied carbon in structural material major products as of 2022, reduce embodied carbon in structural materials by 30% starting in 2025, and conduct whole building life cycle assessment by 2025 for major building and infrastructure projects. Also, uh, fortunately, you described all the details about the lead version 5, but yes, of course, here also as well like lead requirement, and you can take up to like 6 points from the reduction of embodied carbon pathways, depends on what you choose, and also the prerequisite for the embodied carbon that is in lead version 5. Also, there are different cities and municipalities day by day like coming up with the new policies on green buildings and embodied carbon strategy. City of Vancouver here targeting a 40% reduction in new construction embodied carbon by 2030. Toronto, Edmonton, and Calgary and other cities, they're just example of how important that is. So that we know about these, the importance of the embodied carbon in construction, then what we do about it in steel. So here where it comes to our offering. So basically the ArcelorMittal offering of recycled and renewably produced steel as a low carbon emission steel offering, and then with the name of XCarb. What is it? So when we take a look at the steel making, like conventional steel making and the new basically processes for steel making. At the left, we have the conventional one using the blast furnace to make the liquid iron for steel making and using basic oxygen furnace. In the basic oxygen furnace processes, you see that there is a huge amount of CO2 and the operation released. In the blast furnace, which is the most responsible for the overall process of steel making. Um, in the new or the in the other method of steel making, we have electric arc furnace. So electric arc furnace is the process of steel making which with the high voltage electrodes uh, either scrap as a recycled material, or here the direct reduced iron is used to make steel. So it's melted basically in that with that high voltage electrode. So basically it uses electricity depending on the grid carbon intensity. It would result in a low carbon emission steel if the grid is clean or is low carbon. In Ontario, the grid is very low carbon compared to global standard, is like around like 50 grams CO2 per kilowatt hour, and it's a good opportunity to leverage the low carbon electricity to produce steel in this way. So two methods of EAF or electric arc furnace steel making. One is, as I mentioned, with DRI, direct reduced iron, which uses natural gas these days, but there are huge research and development on using green hydrogen for the DRA making process and also biosyngas for further lowering the emission, carbon emission in the steel making. But in the very right side in the presentation, we have scrap-based basically EAF, which uses the recycled steel or recycled material, which is also very important with the perspective of circular economy and recycling and resource usage. So this is the one that we target in the X-Carb. And when it comes to the secondary material, we see how it is in the global scale, the steel demand with the years. When it goes forward, we have more secondary materials and scrap, and we can leverage of it. But in North America, the situation is even better. There are a huge amount of secondary material can be used for steel making. So, and the transition to low carbon requires a transformation the way we're manufacturing iron and steel, of course, and using this secondary material is a high importance. So X-Carb in a schematic can be seen here. 100% renewable electricity guaranteed, and it is certified with a certificate, renewable energy certificate, to ensure that that renewable energy using solar, wind, and hydro is connected to the same grid that our asset is using, and also 70% minimum scrap content to ensure that recycled material to be used in that process. So it can go up to 100% scrap content based on the grade of steel and the application of the steel that is made. So with in places that high impurities matter a lot, we can we can't go with a very like high level of scrap content. We go with usually 75%. Where it doesn't matter, it can go up to 100%. Also, for the whole process, we performed the LCA life cycle assessment according to ISO 14044, and the assessment includes scope 1, 2, and upstream scope 3. That is independently assured and certified by DNV Consulting, and certificates were issued for the XCOP. So basically, X-Carb guarantees the EAF process, minimum 70% scrap and 100% renewable electricity. Now the LCA, we get more close to the LCA process, that how we performed using the standard ISO standard and also cradle to gate. So for the raw material here, this is the boundary by ISO 21930 for the construction. So for the A1, which is the basically raw material supply, and for the transportation, we use the site data, specific data for the FASCO in Hamilton. So that's the primary data that we use. And for the manufacturing, if it's the finished products, for the assessment, we use the manufacturer or industry average manufacturing data for the LCA. We also consider the end of life and recycling, the module D, which is optional to be reported in the EPDs. So these are like different environmental impacts mandated by the requirements in the PCR product category rules to be reported for construction and the steel products. Global warming potential, which is the very high important one, which is associated to the embodied carbon, acidification, eutrophication, smog formation, and non-renewable energy demand. And then as a result of this process, for the X-Carb process, EAF, renewable electricity, and the LCA that I explained, we came up with the EPDs. That's like a commercial asset to ensure the embodied carbon for the steel products, for the flat roll products that at the gate of our company, as well as some finished products, finished construction products that you see here, 5 finished construction products, including steel cladding and roofing, steel deck, cold form section, hollow structural section, as well as corrugated steel pipe, which is used for like culvert and drainage applications in municipalities. And for the for the coils, for the steel coils that goes out of the gate of our facility, we use, as I mentioned, the primary data from our operation. For the manufacturing, the finished products, we use the industry average data for the Canada using the information from associations, Canadian Institute for Steel Construction and Canadian Sheet Steel Building institution. For the corrugated steel pipe, we use the data from Corrugated Steel Pipe Institute. And all these EPDs are third-party reviewed and verified and available free and available on the Dofasco website, which is here the address, and you can access. As a result of the XCarb products, you see here in this graph, you see how the embodied carbon of the steel coils of uh, Dofasco stands versus the North American average and global average. North American average by American Institute of uh, and world steel with the world steel global averages for hot roll coil, cold roll coil, and hot dip galvanized coil. For hot dip galvanized coil, it's slightly higher embodied carbon because of the processes in the galvanization. But in every cases, it's almost half of the um North American average and less than half of the world average in terms of the CO2 equivalent per metric ton of steel as a unit for these numbers. And then this is EC3, the tool by Carbon Leadership Forum for the benchmarking and assessment of embodied carbon based on the EPDs that are embedded in that tool. So in this graph, it shows where the X-carb numbers, the hours low carbon steel offering stands compared to other available basically numbers in the system, EC3 system, which basically offers the lowest carbon emission sheet steel products in North America. And how it's important for the architects, for the designer, building designers, it's very important that they use for their targets, for the basically net zero targets or any GHG emission targets, to use mill specific EPDs or mill specific GHG emission data or reports, because when it's mill specific, it's very transparent and it's can be used with a high confidence in their scenarios for net zero. When it's industry averages, because it's like an average of different facilities, the uncertainty is higher. So that's one thing important about the mill specific EPDs that we offer. And also the recycled content is very important, mentioned before in the circular economy point of view, and making targets for the carbon for the building is also of high importance. At the end, I want to just introduce this Intelligence is a global initiative for showing how steel can contribute to the construction and the advantage of steel in the construction. So for a few years, also ArcelorMittal started the Intelligence case studies for different kind of buildings. These are some of them shown here at the left. So, and that's, we just want to send that message that the whole is not the sum of the parts. It means that you need to define different KPIs with different perspectives, seeing the whole building basically performance. So those KPIs are weight of the structure, environmental impacts related to embodied carbon here, and total cost of building and speed of construction. The details of these case studies and the results are available upon request, and we can present for you. But this is an interesting initiative showing how the embodied carbon of the low carbon steel is showing itself in the overall performance for different building structures, and also uh, how competitive it is versus cement, versus concrete and timber. So the same structure with the three different materials, and we made that comparison, and the results were very promising for the steel. We are in process of implementing the X-Carb offering that I showed in this presentation. Those numbers, those low emission values into this Stelligence initiative to show the competitiveness of the steel in the building constructions. Uh, at the end, if you have any question about the X-Carb offering or our low carbon emission steel, you feel free to reach out to me. And for the Stelligence, our Stelligence project manager, Matthew Winters, will be ready to answer any question or present upon request about our Stelligence projects. Thank you. Thank you, everyone.
Excellent presentation. Thank you so much. So we're going to just through questions at the end of our presentations here. So next I want to introduce Shane Mulligan. Shane Mulligan is a sustainability and technical marketing manager at Heidelberg Materials, where he is responsible for all aspects of sustainable sales and marketing efforts in terms of Heidelberg Materials concrete business in the Northwest region. This includes working with architects, engineers, and designers towards low carbon sustainable solutions in the built environment. He has 17 years of experience in a variety of civil engineering sectors, including a role with the Cement Association of Canada in leading advocacy efforts with government focus on procurement policies and technical promotion of cement and concrete. Shane has a Bachelor of Science degree in civil engineering from the University of Calgary. So Shane, I'll hand it over to you. Looking forward to hearing your discussion.
Perfect. And are you seeing the full screen view of the presentation now?
We are good.
Perfect. Thank you. Thanks very much for the introduction and having me here today. I'll try to keep us on time as best I can as I rip through these slides and leave time for questions at the end. Very quickly, who we are. Heidelberg Materials is a vertically integrated construction materials company specializing in cement, concrete, and aggregates. In Alberta, you might know us better as Inland Concrete or Lehigh Hansen, but we underwent a global rebranding effort back in January of last year, and we're now under the Heidelberg Material umbrella. And we're located in what we call the Northwest region, which is kind of the Ontario-Manitoba border west, as well as the states of Oregon and Washington. So you've all seen the stats, I'm sure, on sessions like this previously, or presentations around embodied carbon, that cement and concrete contribute very significantly to the embodied carbon footprint of a given building, as well as global greenhouse gas emissions. And I think the industry has been very progressive and active and proactive in getting ahead of this issue. We ultimately represent 5 to 8% of global greenhouse gas emissions, largely driven by the fact that we're the second most utilized substance in the world next to water. And as a result, we have a large amount of emissions that we need to reduce. And at the European level, with the Global Cement and Concrete Association, Portland Cement Association in the US, and Cement Association of Canada, over the last couple of years, all of these industry associations have published roadmaps to the goal of net zero concrete by 2050, and highlight all the different technologies and levers that the industry is going to utilize to get towards that goal. As Heidelberg Materials, we are part of all these industry associations and committed to these same targets, but also have our own roadmaps that we've developed at global and national levels, which is ultimately going to bear out in the products that we have, whether it's lower carbon cements, recycled concrete aggregates, or low carbon concrete. And some of the near-term solutions that are likely to reveal themselves, especially in the Alberta market, include things like lower carbon cements. This includes products like Portland limestone cement in place of traditional Portland cement. Also blended cement products. We have, for example, in Alberta, our EcoCem Plus product, which is a Portland limestone cement with 20% fly ash already blended into the product, which provides a lower carbon intensive cement product overall. And I think as an industry moves forward and towards this goal of net zero concrete, you're going to see more and more of these Portland limestone cements and blended cements make their way into the marketplace. Another core lever that we're looking at industry-wide is the use of alternative low-carbon fuels. Cement is a very energy intensive process that traditionally uses natural gas or coal to get the cement kilns up to extreme temperatures. We're looking as an industry to implement alternative fuel systems that utilize things like construction demolition waste, non-recyclable textiles, non-recyclable plastics, et cetera, just to offset the use of those fossil fuels and ultimately reduce the carbon intensity that's associated with those fuel types. We're already implementing these across Canada. Both the cement facilities in Alberta are currently undergoing alternative fuel projects that should start to show themselves on cement and concrete EPDs in the next year or so as they get a year's worth of operations under their belt. But that's one thing to look forward to in the near-term future. Another one is natural carbonation. Many people may be unaware that concrete naturally absorbs CO2 from the atmosphere through its exposed surfaces. It's a process known as natural carbonation or sometimes carbon uptake. It's long been known to happen, but from a carbon accounting perspective, there's not a lot of data that's available on a North American level that's informing these calculations. In Europe, by contrast, they allow conservative calculations for carbon uptake radon and EPD for cement and concrete, whereas there's a lot of different research and development projects going on throughout North America to better quantify it in a North American context. So again, something to look forward to in the next several years, maybe 3 to 5 years before we start to see the results of that bear out when it comes to cement and concrete products. But when we're talking about low carbon concrete, where we're at today, we definitely get the benefit of anything that happens upstream with cement production. But from a concrete perspective, we have a lot of different engineering levers at our disposal that help us to reduce the carbon intensity associated with our products. Some of those are highlighted on the screen here from aggregate gradations, which really looks at improving the particle packing of the concrete and getting more strength out of the skeleton and aggregates of the product, which helps you to reduce the amount of cement that goes into the concrete. Lots of great research and development that's going into different types of admixtures, strength enhancing admixtures, water reducing admixtures, again, that enhance the performance of concrete from a low carbon perspective. The big lever that everyone's likely familiar with, the secondary cementitious materials or SEMs. These include products like slag from the steel industry or fly ash from the coal industry. I'm sure many are aware in an Alberta and prairies context that fly ash and coal are going away as a result of the 2030 goals that the province have set in terms of shutting down coal plants. So certainly the fresh supply of fly ash is likely to disappear over the next several years, but we're not concerned as an industry. There's many decades worth of fly ash that has been built up over the years at different landfill facilities, and it's already in the CSA codes and standards for cement and concrete that allow us to go in and harvest and process that fly ash to create a product that's going to perform the same as fly ash and continue to do the work that it does within a concrete mix and reduce the overall carbon intensity. Cement type generally refers to the use of Portland limestone cement, which is more and more becoming the standard throughout Canada. And you're likely to hear more about that as we move into the future. And then there are some other levers when it comes to judging the performance of the concrete that we're able to pull. Looking at days to strength maturity as an example, concrete's traditionally judged on 28-day strengths. 30 MPa in 28 days. In select opportunities like foundations, footings, piles, any application that's sitting for quite some time before it's loaded, we're able to take advantage of extended maturity schedules, 56-day concretes, 91-day concretes that can significantly reduce the carbon intensity of the concrete product. And then there's an emerging field of digital solutions that we're able to utilize, whether it's artificial intelligence technologies, maturity monitors that provide us feedback into how the concrete is curing live, or load assurance monitoring that looks at the performance of the concrete as it's being transported to site and gives us insight into the plastic properties of those concretes. All of these little feedback loops create opportunities for us to incrementally improve performance of our cement and concrete products. How we measure the impact of all these different levers is through the use of environmental product declarations. At our Heidelberg materials facilities throughout North America, we've invested in the ability to generate product and facility-specific Type 3 EPDs. There are a number of different producers throughout Canada that are undergoing this or have them currently available. and you're going to see it really take off over the next several years. I think it will become the standard as part of doing business as a concrete producer, much like mixed tickets upon delivery. But they're not without their challenges as well. EPDs are very specific to the mixes that they're designed for, and they create some administrative challenges when it comes to what is published, how that's managed, how it's replaced, how it's updated, and then ultimately how it's being used. Worth knowing for concrete and understanding is, most people are concerned with one number on an EPD, which is the global warming potential or carbon intensity. But that one number is generally built of 3 different numbers that are the different modules from the LCA process as part of an EPD. Module A1, of course, is the extraction and upstream production of the raw materials, which in concrete's case is very much disproportionately driven by the cement, or more specifically, the clinker content of that concrete mix. That's the main driver when it comes to all emissions that are associated with concrete. Module A2 is the transportation of the raw materials to the manufacturing facility, and this is very dependent on your haul distances and what mode of transport that you're utilizing. Generally speaking, the transportation of aggregates is the biggest contributor to this module. And I like to use the example of Vancouver as being well advantaged in this space, where most of the aggregates are transported in the Metro Vancouver area using barges, which is about an order of magnitude less carbon intensive than trucking of aggregates. But in a landlocked area like we are in much of the prairies, that's not an option. We have to utilize trucking, unfortunately, or rail in select examples where that might be possible. And as a result, the carbon intensity associated with concrete in the prairies is higher than it would be in Metro Vancouver. Similarly, on the manufacturing side, module A3, that's very much dependent on your energy sources and your climate. So again, picking on Vancouver, it's a very moderate climate, at least from a Canadian perspective, and they run on hydroelectric electricity. If you contrast that to a Fort McMurray, Alberta, we're on a coal-fired electricity, and it can be quite cold throughout the year, so they use a lot more natural gas for heating. And so again, another disadvantage just by being where we are. So all this to say, it's just important to have this understanding of the different contributors to an overall concrete EPD, because where you are will change your overall concrete carbon intensity. You can have the exact same recipe in Edmonton as you do in Calgary, but ultimately it's going to be different by virtue of the raw materials you're utilizing, how far away they're coming from, what mode of transport, and how much electricity and energy you're ultimately consuming. And that brings me to another one of the challenges that we have with EPDs. So right in the product category rule for concrete, it states that concrete EPDs can only be compared to one another if they have the same or superior structural, thermal, and exposure properties. And the unfortunate thing about that with EPDs is that a lot of those properties for concrete are not mandatorily listed on an EPD. And EPDs can vary quite widely with concretes, depending on strength, depending on exposure class, and many different project specific considerations in terms of if it's pumpable or not, availability of raw materials at the time of issue. So really wanted just to highlight for this group on the call today that there's some great tools that are out there, like the Embodied Carbon and Construction Calculator. It's going to be very powerful in time to enable designers to have an insight into what different carbon intensities are possible for different concretes. But right now, most of those concretes aren't comparable because you don't have the context necessarily, unless it's explicitly listed on the EPD, that it's the same exposure class for the same type of application. So it makes the job very hard for designers to interpret these properly, and it makes it hard for the concrete producers to make sure that they're managing that data properly and publishing the right sort of information. Other EPDs that you might be familiar with are the industry average environmental product declarations, and there was the national one that was published back in 2017. And in 2022, there were more regionally specific industry average EPDs. The Alberta one is highlighted on the screen. Generally speaking, the one value that's important to designers, or the one that we'd like to be most important to designers, is the lightly green highlighted column, which represents the recommended baseline for the specific strength of concrete that's being specified. In Alberta's case, that generally refers to a type GU cement concrete mix with 10 to 20% SCM use, depending on the different strength and exposure class that it's addressing. All the other columns to the right are intended more for concrete producers that don't have the ability to generate product-specific EPDs, so that they can attest that their concrete is approximately equal to the different designs that are denoted there and submit those GWP values as part of their ability to demonstrate adherence to a given specification or policy. And ultimately, what they're able to demonstrate through that is about a 10 to 15% reduction, depending on the mix, as a result of using either Portland limestone cement or the higher use of SCMs. The one caution I would issue when it comes to the use of the industry average EPD is that sometimes they're not based on strictly air or no air designs. It is important to pay attention to the exposure class when it's listed, because as an example, some of the mixes are for an exposure class C-XL, which by virtue of the CSA standards actually are representative of 56-day mixes as opposed to 28-day mixes. So there does need to be some discussions between the concrete producers, the structural designers, and the design teams that are setting these different baselines and thresholds for their projects to make sure that there is an understanding of the concrete that's ultimately being called for and what the implications are from a carbon intensity perspective. And to that end, I would highly recommend the use of this document in terms of informing your projects and how to specify lower carbon concrete. This is Concrete Canada's guideline for specifying low carbon ready-mix concrete in Canada, and ultimately provides a step-by-step guidance in terms of generating a carbon budget for concrete, which ultimately has a designer outline all the different concrete elements they're looking at, the corresponding strength and exposure class, and then a corresponding maximum GWP value or threshold. Ideally, that's informed by regionally industry average EPDs, but the designer is just ultimately able to make that decision themselves. The one thing I would highlight from this document, which is very important, is that if you encounter a concrete mix that is not listed in an industry average EPD, or you're dealing with a special case like a highly strength concrete, the recommendation provided is 130% of the corresponding strength class for a given element. So if you had a highly strength footing in this example, you would be taking 130% of that 318 value to represent a highly strength addition of that mix. I can see I'm running a little short on time, but a couple of the key things I wanted to highlight were the gaps that we're starting to see between design level whole building lifecycle assessments and as-built whole building lifecycle assessments. Ultimately, the one that's most important, of course, is the as-built design in terms of what was actually delivered on site. But we're seeing quite a disparity between the design level estimates and as-built because of these highly strength applications. Oftentimes, it's known that certain types of elements in a building, like suspended slabs in a high-rise, are going to utilize higherly strengths, but that's not necessarily being reflected at the budgeting stage for these whole building life cycle assessments. So again, having those early discussions with the general contractor, the concrete producer, and the designer is very important to ensure that's properly addressed. With my last couple minutes here, the only thing I wanted to highlight was that if you're looking at a mix-to-mix level, you have the industry average EPDs available. Some concrete producers are able to provide mix-specific EPDs. They might be able to generate a couple different options for you to look at in terms of 28-day mixes, 56-day mixes. The EC3 calculator can help identify who those concrete producers are. And in the not too distant future, we're going to have carbon capture utilization and storage in Alberta. One of the key levers in the Canadian Net Zero Action Plan is the use of carbon capture and storage technologies. And we're blessed in the province of Alberta that we're going to have the first carbon capture utilization and storage plant in Edmonton. Heidelberg Materials is in the process of making a final investment decision to go forward with this project, which would ideally be completed in 2027, giving us net zero cement in 2027, 2028, which is something to be quite excited about in the province of Alberta and across North America. And with that, I will yield my time to make sure that there's some left over for questions. Thank you.
Thank you so much, Shane. We already have some questions that are kind of popping in here, but I think it's really great that you're highlighting as well that there are some challenges that we're kind of dealing with in terms of LCA is still quite in its infancy, and we're all kind of trying to figure things out as we go along. And hopefully these NRC guidelines, as well as other additional guidelines, are helping us out as well. So we actually had a question for you, Shane, from Camille. Could you possible to define exposure class? I know you went over just a little bit there in terms of things to consider, but is there some great documents that would be advisable for exposure class, or some great guidelines that you would provide in terms of people who are doing early LCA analysis?
Yeah, so the best guidelines for exposure class is the CSA specifications for cement and concrete. It's A23.1/A23.2. It provides a breakdown of all the different exposure classes that concrete might be subjected to in terms of, is it in a high chloride environment? Is it a high sulfate environment? Is it subjected to freeze thaw, et cetera? All those impact how the concrete is ultimately going to be designed to withstand all those different exposures that they might be exposed to. And so it is important to bring them into consideration when designing and selecting your carbon intensities. Oh, you're on mute, Christina.
I feel like I'm new at this apparently now. So I have a question from Trevor for both Shane and Fareed here. In terms of the research and development budgets for both of your companies in order to achieve low carbon materials, is this, I guess the question is, how are the budgets? Are they being generous? Is it innovative in that sense? I would be interested to hear from both of your perspectives.
Jump in first there. Yeah, certainly research and development is a key driver at Heidelberg Materials. We have an exclusive innovation and R&D group in our global location in Heidelberg, Germany. And we've invested quite heavily in the field of carbon capture, utilization, and storage. That plant that I mentioned in Edmonton is going to be a $1.4 billion project, which is quite the investment overall and is definitely indicative of our commitment to enhancing our sustainable efforts.
Here, here in Hamilton, we have a team of decarbonization for energy and CO2. They're intensely working on decarbonizing the steel for 3 million ton reduction by 20 ton CO2 reduction by 2028. And there was a investment last year. It was on 20, I think, a few years ago, to reach those targets. But they're working more on the incorporation of biochar in steel making different processes, and also like testing how hydrogen also can incorporate to the DRI and the EAF process that I explained. But from every aspect, they're working on the decarbonization of steel.
I have a question here from Granite. Hopefully that was correct here. This is for you, Fareed, here. Are you able to report on RECs or REC benefits on environmental product declarations? They say that they're not very familiar with steel EPDs, but wanted to hear more about reporting the RECs on EPDs as part of the global warming potential.
Yeah, sure. So the EPDs are basically are modeled based on the LCA background reports. So the LCA background reports are modeled. We're using what we use is the copy software, and we use the databases primary in our sites for the A1 module. And in that case, we use the electricity with basically the grid in Ontario, and that's renewable energy certificates ensures that the renewable electricity that we report on is connected to the same grid that we use. Yeah. Not sure if that was the answer he was looking for.
It was a good answer regardless. So we do have just 1 minute left technically in our schedule here. I know that I'm able to stay for a little bit afterwards if there's any questions. I'm not sure about yourself, Shane and Fareed, but before we depart, I just want to quickly share my screen just so that we're able to provide our contact information for those of you who may want to connect with us again. So here are some QR codes for CLF Alberta, myself, Fareed, and for Shane. I checked them, they should all work. If there are any additional questions, I did not see anything in the chat just yet, but you're welcome to unmute yourself as well if you wanted to ask a quick question before we depart. All right. Well, I do believe that there is also, oh, there is a question that maybe came through. Oh, thank you. Well, thank you very much, Veronica. I know that we do have a quick survey as well for people that would be able to quickly fill that out before we depart today. I believe it's just 2 questions long. So Andrea, if you're able to throw that survey up for everybody. And I just want to thank you everybody again so much for being here today, for taking part in our event here with CLF Alberta, as well as to Shane and Fried for being able to speak and present on concrete and steel. I think it's really exciting in the industry right now.
Thank you.
Oh, it looks like the survey is just in the chat there, but again, I can stay online for a little bit longer if anybody else has any additional questions for myself. And again, thank you very much for joining today. Really appreciate your time.